Well, if anyone was in any doubt that this show is produced live, you just had confirmation of a quick misfire there on the countdown.
You did.
You said you can't believe that's never happened before, Ben.
Oh, yeah.
I'm sure it has.
I think it's only the third time.
Is it? That's pretty
Yeah.
good.
It's not out of how many? 283?
284?
Anyway, hello, willkommen, bienvenue, konnichiwa, ni hao, jambo, marhaba, good day. Good day, mate. It's time for the Army Synchronization yet again, episode 283 on Sunday, the 4th of June. I'm Phil.
I'm Ben.
I'm Matt.
And tonight we're delighted to be joined by Marc Young, a member of the Comet Research team. How you doing, Marc? And why can't we hear you?
I'm good, guys. Thanks. How's it going?
Gosh, I thought I was going to fail again, technically. We're doing really well, and we're very happy that you to be able to talk with us tonight. So thanks for coming along.
Yeah, cheers, mate.
You just cut out for me for a second there.
Yeah,
it's good to be here, guys. It's a bit late here in Australia, but it's happy to show up.
Yeah. Now, you're a member of the Comet Research team who is appearing at the forthcoming Cosmic Summit 2023. So tell us about that and when it's kicking off.
Yeah, so it's in Asheville, North Carolina on the 17th and 18th of June. It's the Saturday and the Sunday there. And we've got quite a few guests speakers that people will know, like Randall Carlson and Russ from the Cosmography podcast, and we've got Ben from Uncharted X there. He's talking about his recent work on the jars from Egypt, so that's going to be interesting.
Nice.
Oh gosh, yeah, I saw something they released recently. It's these. Are they made of granite, or diorite, or something? These vases, and the tolerances which they're made are absolutely astonishing.
Yeah, they're extremely precise. So they think they're made with computers or something. So I don't really know too much about it, but
it's cool because most people think of the pyramids or the Sphinx, but it turns out that these really tiny things, these little vases, jars, are probably more enigmatic in a way because of how thin they are and the sort of precision and the symmetry involved in the design and manufacture. It raises questions, doesn't it, that we don't have adequate answers to.
Yeah, well, the weirdest thing is it's not just the precision, it's the fact that they are some of the oldest artifacts from Egypt. They're from the First Dynasty, which you wouldn't expect. Typically, things get better over the time, but they got worse. And later ones were reproductions that were from softer materials and stuff. So, yeah, it's really interesting.
Yeah, I think they found them under, is it the pyramid at Dashur, which I think, or is it the Step Pyramid? Or are they both the same thing?
It's one of those. Yeah. I'm not big on my Egypt stuff, but yeah.
And it's not like they just find an odd one here or there. There's hundreds and thousands of them.
There's thousands of them, yeah.
It's nuts. But that's not really your specialty, Marc. You're into these tiny little balls, aren't you?
Yeah, that's right. Yeah, microscopic stuff.
Yeah, microspheru. I can't say it.
We had a go, didn't we?
Yeah,
None
of us can say microspherules.
How do you say it, Marc?
Yeah, it's microspherules. Yeah, you guys got it right.
Close enough.
Okay.
And these are regarded as sort of an impact proxy. Is that correct?
Yeah, that's right. So they're made when the impact plume interacts with the sediment on Earth. So they're not extraterrestrial material themselves. They're material that's been from the ground it's been melted and thrown about violently. So it's basically spatters of melted sediment.
So what's like the process? Can we get granular with the microspherules in how they're
Sure.
made?
I actually have an image describing, if you guys want me to share.
Certainly.
Yeah.
We'll try.
Do you not have a few on your desk, Mark?
I don't, but if I did, you wouldn't be able to see them because they're smaller than a human hair. So,
Wow.
yeah. Why isn't that working? Yeah.
Thought it'd be like a paperweight or something.
A paperweight, yeah. I mean, oh right, it was. Oh
There you
look, we've got an
Excellent.
image.
Yeah, so basically, this is using a nuclear detonation as an example, but here we have the environmental particles. They're entrained in the impact cloud up here, and they literally condense into vapor. As they cool, they form these little spherical things, and they end up being differentiated. They have like a silicate core, and they have a little thin iron shell on the outside.
So, Mark, this isn't the same as atomic glass, is it? Where I think that's just where loads of shit gets melted and they find, after.
It's basically the same process makes both.
Right.
So atomic glass is just are microspherules, but they're not magnetic. They don't have high iron content like these do.
Okay.
Yeah.
Cool.
So vaporized soil, metallic structure, and radionuclides. Is that right?
Yes.
So that all comes from the Earth's surface when the thing hits.
That's correct. Yeah.
Now, does this mean could these be produced from an impact and an airburst?
Yes. Well, so both impacts and airbursts do produce these, but we at the Younger Dryas boundary, we think these were made by airbursts. And this nuclear detonation here is actually an airburst. It's not detonated in the ground. It's detonated on like an iron tower, like 100 meters up. And then it sucks everything up from the bottom into the air in the plume.
Mad shit.
Wow. Because that's how like nuclear bombs work, isn't it? They detonate them. They don't actually hit the ground.
No.
Yeah, that's right.
And the force of it sucks all that stuff up. That's mental.
Yep.
Pretty big.
And so you mentioned magnetism. How does that work? How does that differentiation occur?
So in the diagram here, we have in blue, it's the silicate, so normal sediment like quartz grains, sand grains, all that stuff. And then because the melting temperature of quartz and iron are different, the silicate condenses first, and then the iron condenses on the outer shell. So, and that's how they become magnetic with the iron content.
Wow.
Magnetic jacket.
Yeah. So I'd always assumed that these things were made of just one substance, that they were little balls of one thing like iron or whatever, but they have multiple components.
And sometimes they are hollow, which is interesting in itself, but mostly they're not.
Why is that interesting in particular?
Well, I would assume that in order to be hollow, they need to condense on something, and whatever they condensed on isn't in there anymore. So it could have been something that was solid and then became a gas later when it cooled, or
like a seed.
It could be carbon stuff.
Wow.
I've heard about, is there something to do with platinum related to these kinds of spherules?
So platinum is a signature of the Younger Dryas boundary impact, but it's not actually contained in these spherules at all.
Right, okay.
Some of them have enriched quantities of extraterrestrial metals like platinum, iridium, nickel, all that stuff. But that can be from the Earth's sediment itself, but it could also be from the meteor, because that gets vaporized as well and mixed in with all the terrestrial sediment. So some of them have tested for high quantities of those metals, but most of them don't have much at all, if any.
Mm-hmm.
Right. So presumably, even in an airburst, some of the material that's extraterrestrial makes it onto the surface.
Yes.
Right. So that's why. Is platinum exclusively extraterrestrial then? Is that why it's an impact proxy?
No. So the reason that it's considered an impact proxy in this case is because it's very rare in the Earth's crust. When the Earth formed, all the iron basically got sucked into the core, and these metals love binding to iron. So most of the platinum group elements and rare earth minerals, they were sucked into the core with the iron. And that's how we know, for example, how the KT impact was found with the iridium layer, because there was a really high concentration of iridium, and people were like, how did that get there? And the answer was that it came from the asteroid.
So the KT impact, that would be the one that wiped the dinos out, would it?
That's correct. And it's actually not called the KT impact anymore. The bloody scientists changed it to KPG for Cretaceous Paleogene. I don't know why Cretaceous is a K, but maybe it's just like a German thing or something.
Oh,
Yeah, or Greek.
I'm just wondering, because we've just gone straight into talking about this impact and spherules. Yeah.
Mm-hmm.
Whether just for most people, I assume, know what we're talking about here, but just is it possible for you to give like a short overview around what is that we're actually talking about in terms of what
the event?
Yeah, the hypothesized
Don't mention
event.
the event.
Yeah.
Sure. So the idea is that about 12,800 years ago, at the start of the Younger Dryas, the theory goes that a major cosmic impact happened. And early on, around 2007, when it was first published in the scientific literature, it wasn't really well understood. Like they were finding these exotic proxies in the sediment, and they're like, well, how did these get here? It must have been from an impact. And so early on, when other groups were trying to test the hypothesis, they didn't do a very good job, to put it lightly. And so it came to be prematurely rejected by the scientific community. And in the last 10 or so years, the science has gotten much better, and we have a much better understanding of what these materials are, how to find them in the sediment. And yeah, so around the Younger Dryas onset, there's a lot of ecological, I suppose, oddities or anomalies, I guess. Obviously, the megafauna extinctions are a big one. Up to 50 genera or more than 50 species of megafauna, like the mammoths, the ground sloths, and all that. They all went extinct around this time. And for a long time, it was thought by scientists that it was humans that killed them off. And that happened to coincide with the arrival of the Clovis people in North America. So they put two and two together and said, well, it must have been the Clovis people who killed them when they arrived. But
I like the way George puts it. He said the predominant hypothesis was overkill, that the humans did it. And then the competing one was over ill, I think. That there was some pandemic, but what it really was over grill. All the mammoths got grilled, and they found them like flash frozen, haven't they? Like they've been crushed down at the knees. These giant mammoths.
Yeah, so there are a lot of those type of finds, but those typically don't date to the Younger Dryas. They date to earlier events.
Oh, that's interesting.
Or like Le Champ, maybe, or what was the other one? The one in Asia.
It's interesting you say that because Le Champ was about 42,000 years ago, and that's around the time that these mammoths and stuff died. So that's interesting in itself. So it's about 37 to 45,000 years ago that these other hypothesized impact events happened. So there's at least one paper by the Comet Research Group that found have you guys seen the Joe Rogan podcast with the Alaskan boneyards.
I don't know.
Is this the jumbled up bones?
Yes, so they're pulling hundreds of thousands of megafauna fossils out of a single deposit, less than 2 acres in size. And the Comet Research Group did some work on this in 2017, and they found that inside the skulls of these animals were these microspherules from impacts.
In the skulls?
Inside the skulls, yes. So obviously they weren't embedded in the skulls during the event, but as the sediment filled up the skulls over time, the spherules made their way in there. So they were in the same deposit as the bones, and they made their way in there.
So it's the idea that there was an event that killed the mammoths, and then then gradually they got filled in. What, with a second event or the same event that killed the mammoths, produced the microspherules? So
the Comet Research Group seems to think that there were multiple large impacts or airbursts over the Alaskan and Siberian regions, and they basically entombed these mammoths and other megafauna, really, very quickly. So they just covered them in sediment, basically. Yeah.
Wow. And it's I mean, it must be so hard to make any sense of it, because there was a massive ice sheet at the same time over North America, and which melted away. And you think of all that churning and swirling, like trying to pick it apart 12,000 years later, it must be nigh on impossible.
Yep, it's definitely difficult. And you wouldn't expect, if there's a big ice sheet over there, you wouldn't expect them to be able to excavate that material, and you wouldn't expect those remains to be able to be concentrated like they have been. So it's really quite interesting.
Yeah, gosh, like mammoths falling off a cliff. And they're getting buried. You mentioned that, just to go back to the microspherules, where do you find them?
So they're found in a very thin layer of sediment that dates to the onset of the Younger Dryas, all around the world, basically. Everywhere they've been looked for, they've been found. So
does this tie to the black mat layer?
Yes. So the black mat layer is a several centimeter thick layer. It's composed of mainly organic materials like algae and plant remains. It's often thought by people that it's a burn layer, and that's not exactly true. There's not much charcoal to be found in there. And it's basically the result of a post-catastrophe wasteland over 1,000 or so years of the Younger Dryas. So the Younger Dryas is a cold period that went from 12,800 to 11,600 years ago. And it was very abrupt in its onset. So temperatures in Greenland fell by about 8 degrees Celsius within a decade or a few decades or so. And I mean, if that happened today, it'd be game over for civilization. Actually, the movie The Day After Tomorrow is based on the Younger Dryas event happening in modern times. So yeah.
It's Roland Emmerich, wasn't it?
It is. It's an all-time classic.
I've got. You won't believe this, Mark, but I'm looking at a wall, a picture on the wall, and it's a picture of a signed picture of Dennis Quaid from that movie.
Nice.
It's a pictorial reminder, isn't it, of what we survived?
Yeah.
Is Moonfall an accurate representation?
I haven't seen that movie, but I've heard
don't bother.
Do bother.
Oh well, yeah, do bother.
It's a banger.
It is funny. It's funny in its ridiculousness, but as like a scholarly gentleman that you are in the realms of geophysics and such, you will probably tear your hair out watching it.
I was just quite interested that you said, the black mat is thought of as like a burn layer, I think you said, or misrepresented as such.
Yes, that's right.
So, because that's kind of how I made sense of it. It was like everything was on fire for like ever. So I'm just wondering, why is it black? Yeah.
Well, it's basically it's a lot of organic material. So I don't really know why. Well, it's like black mold, I guess. Why is black mold black?
Right.
So there's lots of organic material in there, like mold and algae and diatoms and stuff and things like that. But it's also not always black. It's black in most places, but in some areas it's gray, it's white.
Right.
Yeah.
Okay.
So it really depends on the area.
And
I mean,
sorry, go on.
sorry, some of the places do have charcoal in there, but they're not really high concentrations or anything that would suggest like a continent-wide wildfire or anything like that.
Just a few hardy survivors burning effigies to make this go, make this end, bring back the sun. I mean, the implication is, as well as you drop in temperatures, if the culprit is cosmic impacts, the amount of ejecta that's going in the atmosphere and water vapor, you're not going to see the sun. And that's why there's a die-off in vegetation worldwide. Is that a fair summation?
Yeah, exactly. And a 2018 paper by the Comet Research Group, it's based on 152 charcoal records from lakes and ice cores and ocean cores and all that stuff. And they calculated that up to 9% of Earth's biomass was consumed by wildfires in a very short time. And that's like obviously an insane number, but it's not. If you're picturing a whole continent on fire at once, that's not what it is. It's like patches of wildfire here and there. So,
but again, that's going to have the same effect of the emissions coming off 9% of all biomass burning. That's going to have an implication. I'm guessing it's like a snowball effect, isn't it? Then with this climate,
more or less. So in that paper, the Comet Research Group calculated that it would have formed like an impact winter, which is like a nuclear winter basically, and that would have blocked out the sun for a week or a few weeks, and it wouldn't have been complete blackness, but it would have been quite dark.
Sounds like Lancashire. It's a couple of weeks, crikey, we can manage that. There must be more to it, Mark. What happened after the 2 weeks of the sun disappearing?
Well, I mean, so it's thought that might have contributed to the cooling effect. It was very, very quick cooling, obviously, but it didn't last the 10 or 20 years that it took for those temperatures to drop. So there would have been other forces at work as well. And it could have led into a feedback loop of sorts, but it would have been combined with other things. Like one of the theories is that several of these impacts or airbursts happened over the northern ice sheets. And it's pretty well established that there was a major influx of meltwater into the oceans at that time. And that's the main theory, the universally accepted theory of what actually caused the Younger Dryas. But, I mean, without the impact part.
Right.
But
yes, they blame... So don't they reference sort of underwater dams or something breaking? So
the traditional view is that Glacial Lake Agassiz in the US was full of meltwater and it discharged into the oceans at that time. And they also think there was a Heinrich event, which is basically like an armada of icebergs breaking off of the ice sheet and melting on the surface of the ocean. And because fresh water is not as dense as salt water, it forms a layer on the surface. And that layer then freezes because it doesn't get mixed with the salt water. And that prevents warm water from reaching the surface. And the atmosphere, the ocean atmosphere circulation is a major component in global temperatures. So if there's no warm water making it to the surface, there's no heat going into the atmosphere. So, yeah.
So what's your contention then against the Lake Agassiz dam breaking?
So I guess for one thing, Lake Agassiz didn't have enough water in it to do this. And so there's been arguments for decades over where the water from Lake Agassiz drained, and they've identified like 3 different outlets that it could have drained from. but they haven't figured out which one it was. There's arguments back and forth. And I would contend that an impact into the ice sheet, or several, would have caused water to flow off of the ice sheet, or even into Lake Agassiz and discharge from all three at once, basically.
Yes, you can have your cake and eat it in that respect.
Yeah, yeah. And I mean, if you look at the climate graph for the last 50, 100,000 years, you see quite a few of these events, and it's pretty well established that these other events were caused by normal deglacial cycles. But the Younger Dryas is quite different to those in several ways, and an impact of the source of that meltwater isn't like far-fetched or anything. It definitely would have led to a discharge of significant proportions into the oceans. So
when you say,
and I mean,
sorry, go on.
Sorry, no.
Oh, when you say the Younger Dryas was different than other events over the last 100,000 years, is that to do with the speed of the onset?
Yeah, so the speed of the onset is one thing, and also the speed of the termination as well. So the cooling happened in 10, 20, 30 years, but the termination happened in about 10 years. So if you could picture, so currently humans are facing extinction with a global temperature rise of 2 degrees Celsius over 100 years. But we've got 10 degrees Celsius in 10 years at the end of the Younger Dryas. So basically, I mean, if you look at the temperature chart, I'll share this as well. So let's move this here. Now share.
Oh wow! So these.
So this is the last 90,000 years or so, and here's the Younger Dryas. But you can see here's the previous interglacial, and here's the glacial period, and you can see a gradual rise out of the glacial period into the Holocene here, but it's truncated by this major event here. So it's almost like the Younger Dryas was preventing the warming, and it built up under whatever the Younger Dryas was, and then forced its way out at the end quite violently. And obviously, you look at this rise here, and you see similar rises all throughout the glacial cycle. But
oh my gosh,
those weren't as abrupt.
It literally just spikes, doesn't it, intermittently?
Yep.
Where these temperatures derived from? Is this Greenland ice core stuff?
Yeah, that's right. So Greenland ice core from oxygen-18 isotopes, and this is temperature in degrees Celsius on the side here.
And just look how, the alarming thing is, look how stable it's been during the Holocene over the last 10,000 years.
Exactly. Yep.
And if anything, it looks like a downward cooling trend.
It does, doesn't it? Yeah.
And I mean, some other temperature graphs, they've been downplayed recently, obviously, with this whole anthropogenic global warming. But temperatures were actually higher during the Holocene thermal optimum, the medieval warm period, and several other times throughout the Holocene. Temperatures have been higher than they are now.
Well, the thing is, the graph they usually show us is average temperature change, isn't it, rather than actual temperature.
Yeah.
It's damn lies in statistics.
Okay.
But yeah, it's good to know.
This is interesting. It's not far off 90,000 years ago, essentially.
Or the temperature today.
Yeah. That's what it seemed like anyway.
Yeah, well, actually, in the last interglacial, temperatures were several degrees warmer and sea levels were several meters higher than they are today. So you don't often hear that, but that's the truth of it.
Something I heard recently is that the glacial period is actually the norm, and that interglacial periods are generally the short bits in between them.
Well, yeah, looking at this graph, that seems to be true. So we've got 80,000, starts about 80,000 years and ends about 10,000 years ago for the glacial period.
Yeah.
And then the interglacial periods are much shorter. And if you look at a climate chart of the last few million years with all the other interglacials plotted on them, our current interglacial period is looking like it's about to end and plunge back into the ice age. So
Hooray!
yeah.
This is something that I've heard around, you know, global warming and all the rest of it is
So it's global climate warming change.
sorry, global climate warming change.
Yeah.
Is that this sort of man-made production of CO2 is actually preventing us going or slowing the cooling of the planet, basically.
Heretic!
That it's actually
How
helpful
dare you.
in some kind of way.
Yeah, I mean, people like Randall Carlson say that, and obviously he's right that we don't want to be in an ice age. Like humans thrive in warm periods. If an ice age were to happen, we'd all be gone, basically. We'd be bands of hunter-gatherers again. We wouldn't be farming. I mean, we could farm indoors in factories and stuff, I guess, but they're working on that technology. But yeah,
I mean, just to play devil's advocate, that chart was from the ice cores, the Greenland ice cores. I mean, how can we be sure that that's an accurate proxy for temperatures across the globe?
I mean, it's pretty well accepted by science that it is, and that it's compared to modern observations, and obviously the ice is still accreting there, so we can see that the oxygen isotope values match up to what we would expect them to be. But there's always the possibility that they're not. Obviously, Greenland has only had ice on it for it only goes back like 300,000 or 400,000 years, whereas Antarctica goes back several million years to the start of the Pleistocene, basically. So Greenland, the ice sheet in Greenland was completely gone at some points during the Pleistocene. So,
well, weren't the Vikings farming on Greenland at one point?
That's right, they were. Yes, there was much less ice there than there is today, just a few hundred years ago.
Yeah, but I guess if you can, I'm guessing so that this Greenland ice core data is then calibrated with other stuff like you mentioned. I mean, would tree rings be another way they can calibrate that?
Yep. So the growth rate of tree rings and the amount of radiocarbon they contain, they've done quite a lot of work reconstructing past climates through those, and they seem to match up with the ice cores as well. And you've got marine cores as well. As ice sheets calve off into the ocean, they drop their sediment in these cores, and you can reconstruct where ice sheets were at a certain time. So yeah, I mean, there's several decades of science that all say that this is what's happening. So
I've heard the argument online that you know that the temperatures could have been different in different. Oh no, I'll tell you what, I'm getting confused. It's the Roman warm period and the medieval warm period.
Yeah,
I've heard people argue, well, just because we have all this writing that, you know, people were growing grapes in southern England and whatnot, doesn't mean that it was warm across the globe. And you know, I guess that's a fair argument. Maybe it was cold, you know, not necessarily warmer in the southern hemisphere or wherever, because we don't have written records from all over the world to compare, do we?
That's right. Yeah. Yep. Pretty much.
Well, I mean, you just got to go what you got, haven't you?
That's right.
Do. Let's go back to the spherules. Focus on the spherules. Now, you said they're tinier than a human hair. How do you know you've even got them, and how do you get them?
So basically, you get the sediment from the layer you want it from. You run it through a bunch of sieves with different sized mesh, and that separates them into different size portions. So you've got anywhere from 1 millimeter down to, I think the smallest I've got is 28 microns, which is 0.0028 millimeters.
Right. Well, I've got a sieve in the kitchen. Could I have a go in the back garden?
You'd be able to get something, but you probably wouldn't be able to. You probably wouldn't be able to sort out these.
This must be like proper, highly engineered sieving tools you're using then to get something
Exactly.
so tiny.
Yeah, they're scientifically calibrated, and yeah, I don't know how they manufacture them. It's wizardry, basically. But yeah,
Same guys who made them balls in Sakara.
So I think you previewed a slide before about the spread of the spherules. Could you just put that
so
up?
it's not necessarily all spherules, but this is the spread of the Younger Dryas impact evidence.
And I'm guessing, do you find these things above the black mat but not beneath them?
So they're directly beneath the black mat in direct contact, but they're typically not found inside the black mat. So is that coming? Yeah, there we go. So this is a map of all the sites where the Younger Dryas impact evidence has been found. This one down here in South Africa, there's only a platinum anomaly that's been found there. There's no actual impact evidence there. It's just the geochemical. So the idea is that the platinum would have been dispersed through the atmosphere for a period of maybe 10 years following the impact. And it's possible that the reign of impacts lasted for a decade or so. And it wouldn't be like a full-on bombardment for that whole decade. Like it would be twice a year, maybe. There would be a few here and a few there. But yeah.
Are you a believer that it was linked to the Taurids and that we went through that cosmic shooting gallery twice a year in late October and the other one?
So that's almost certainly the type of event we're dealing with, but whether it was the Taurids or not is the question. Right. So there's not a lot of evidence, or there's basically no evidence at all to tie them to the Taurids, other than we know the Taurids are there. We know they've been impacting over 20 or so thousand years. We know that Earth would have swept up some of the debris. So we're basically just guessing that might have been the source, but that doesn't have to be the source. Like there's other meteor streams out there, and there's even other disintegrated comets that don't form large complexes like the Taurids. So it's not really well known, but back in 1883, a Mexican astronomer made an observation that he didn't understand, and it wasn't until maybe 2011 or so that it was revisited by astronomers, and they actually realized what it was. It's called the Benilla observation, and it's more or less. Okay, so it was 1883, and it was basically a swarm of about 3,300 comet fragments. And they ranged from about 160 to 300 to 3,000 feet in diameter. That's about 60 meters to a kilometer, more or less. And there was a swarm of 3,000 of these, right? And they barely missed Earth by between 330 and 5,000 miles. They passed in front of the moon, basically. The moon is 280,000 miles away, and these passed 5,000 miles.
Wow.
So in 1883, we very, very, very narrowly avoided a Younger Dryas-like bombardment event.
Nice. Where are they now, Mark?
Could be anywhere. They could be raining down tomorrow.
Well, I mean, something the size of a kilometer. What sort of damage could one of those do?
If it's a comet, a lot less than an asteroid. It could be chunks of ice, and they wouldn't do much damage at all. They'd mostly melt in the atmosphere. I mean, they'd still project their energy to the ground, but And I mean, it could be rocky, chondritic cometary material, but I mean, it certainly would have been catastrophic. It would have been civilization ending if it had impacted Earth.
Yeah.
It wouldn't have been like an extinction event like the dinosaurs, but it would have been like a swarm of Tunguska's impacts. I don't know if your listeners know much about that. We can go over that a little bit.
Well, I was just going to say, yeah, just because that's something that quite a lot of people are familiar with, just in comparison to size of the Tunguska event.
Yeah. So the Tunguska impact was about 60 meters in diameter.
60 meters?
Yeah.
It's a baby.
Yeah. Yeah, exactly. And this was a swarm of 3,300 Tunguskas.
Oof. Filthy.
Yeah.
And that Tunguska thing was an airburst, and that flattened the forest for kilometers around it, didn't it?
Yeah. It flattened about 2,000 square kilometers of forest.
Wow.
Yeah.
So that's the thing, isn't it? So if, like, these things hit a population center, as it's kind of termed, it's like game over, isn't it? I'm just wondering, what would happen if they did an airburst like over the Pacific Ocean,
So there probably wouldn't be much consequence at all, really. There'd be a wave a couple of meters higher that would hit whatever coastlines it reached, but it wouldn't be like a massive tsunami or anything like that.
Okay, let's pray for the Pacific then.
Yeah. And I mean, if Tunguska had struck at the same latitude 2 hours earlier or later, it could have completely changed the 20th century. Like if it hit Moscow or it hit Britain or anything like that, like it would have been a very different time in the 20th century.
Yeah, just like anywhere Central Europe, that landmass, Western Europe, certainly.
It just so happened that it hit over the Siberian tundra. There was only indigenous tribes nearby. Yeah.
It's crazy. So just to clarify as well, on this map, because you had the Carolina Bays up before, just for the listeners, where is the idea then where the actual airburst occurred, or where the impacts are supposed to have occurred then on the globe?
So there's currently about 5 or 6 different locations that we are confident these airbursts occurred. The most confident is in Abu Huraira in Syria.
Oh, really?
Yes. So at the time, 12,800 years ago, the people there were just making the transition from hunter gathering to farming.
Right. Unlucky.
And yeah, pretty much. And obviously, when the Younger Dryas started, they couldn't farm anymore because of the cold weather. So, yeah.
So where else? So we think Abu Huraira is the most confident. Where were the other ones that are hypothesized?
So there's Melrose in Pennsylvania, Blackville, I think it is, in North Carolina. And those are the 3 main sites that are well published by the Comet Research Group. But there are a couple of other sites that we think happened, but we haven't published much on them yet. So there's one in New Jersey. And there was another one somewhere else. I can't quite think of it at the moment.
Just looking at this map where you find this map's strictly speaking spherules, is it?
No, so I think spherules have been found at most of these sites, but any of the Younger Dryas impact proxies. Right. Yeah.
I was just wondering why, because looking at Africa, the continent, there's very little there. Is that due to a lack of testing, or have tests been done and nothing's been found?
Yeah, so there's been no other work done there. The only reason this spot is down here is because one of the professors at the University of Wits University, I don't know the actual name of it, but he did. So there's a lot of work there that's been done on reconstructing temperatures using vegetation proxies. and he went back to those cores and he tested for platinum in them, and that's the only reason that marker's there. And there's been no work done at all throughout most of Asia or Oceania. There's no work done in Australia.
Wow. And so are these impact proxies on the map tied to the Younger Dryas? How is that to do with stratigraphy?
Yeah, so they're all found in the layer that correlates to the Younger Dryas boundary, found directly below the black mat. Yeah.
Wow. You know, if you were a betting man, Mark, would you suggest that you're going to find these everywhere on the planet if you look for them?
I would say so. The platinum anomaly, definitely, because that was dispersed through the atmosphere. But whether or not the microspherules and other impact proxies occur would depend on whether there was impacts that happened nearby.
So is there, going back to the spherules, is there a lot of different sizes and different compositions of spherules related to this event?
Yeah, so the spherules range anywhere from about 10 microns up to 150, 200 microns, and that's 0.2 millimeters, 200 microns, 0.2 millimeters. So they're all smaller than 1 millimeter.
0.2, so 20, yeah.
Yep.
Less than a quarter of a millimeter in diameter.
Yep.
God grief. So can you see these with like a normal microscope, but do you have to use one of those electron microscope things?
Yeah, so most of them are visible with a normal microscope. That's how you look for them and isolate them, and then you put them on little stubs for examination with electron microscopy.
And how do you figure out what they're made of? Can you like cut them in half?
Yep, that's one way. But typically, with electron microscopes, they typically have a chemical analysis instrument built into them. So it shoots a beam of electrons at the sample, and that causes any atoms in that sample to kick off an electron. And by measuring the voltage of the electron that gets kicked off, you're able to tell what elements are on there.
And is this your main sort of area of research now, analysing the microspherules?
It was last year. I did that for my research project for my Bachelor of Science honours. My PhD research is totally different to that. I'm not doing the Younger Dryas stuff anymore. I am working on Younger Dryas stuff for the Comet Research Group still. But yeah, so my research has switched focus a bit.
What's your PhD on, Mark? Can't give us spoilers like that.
I'm doing some paleoclimate reconstructions on a desert lake system in the center of Australia, basically.
There's a lake?
The idea...
Sorry.
So there's a chain of lakes. There's probably 100 or so.
Oh, right.
And they're in the desert. And basically, we're trying to determine when they were full, because they would have been able to sustain in large indigenous populations there, and we're basically looking for new archaeological sites out there.
Fantastic.
Oh, so are they empty now? Is what you mean? Or has it actually got water in them?
So they're wet part of the year,
Right.
but some of them are completely dry.
Okay.
So my PhD is being done in conjunction with another student's PhD, and they're working on a different set of lakes in the same area, and those are basically completely dry. They're only fed by groundwater now. So
Okay. Yeah, because when I think of Central Australia, I just think of it as like a giant desert, basically, and
yeah.
Maybe mining. Is mining going on there? Essentially,
Pretty much.
Mm.
Yeah.
There seems to be a lot of debate about how people and when people settled in Australia. Is there hope that your work and finding potential sites to do archaeological work might help clarify that story?
Yeah, that's the goal. We're hoping to find the new oldest archaeological site. So traditionally, it's been pretty well accepted that indigenous people arrived here about 55,000 years ago. But in 2017, there was work that put them here about 65,000 years ago. And that was a bit of back and forth, but it's almost universally accepted here now that that's a pretty good date for when they arrived. But the problem is we don't have any other sites from that age, so it's difficult to be sure.
Things just keep on getting older, don't they?
That's right.
Yeah, cheeky quoting him. We've managed to get through this whole podcast without mentioning the controversy.
Who shall not be named.
Don't let me. I was going to pull Stig up then.
I know. Yeah.
But yeah, anyone who's not on Twitter who has been living under a rock for the last few weeks, there was a lot of controversy, wasn't there, over this Cosmic Summit? And that's part of the reason I reached out to you, Mark, was to I wasn't expecting a reply or anything, but just to say how well I thought you comported yourself in the manner befitting a gentleman.
Oh, that's a good sentence.
Well, thank you. Yeah, it was pretty difficult. Obviously, it's pretty rough when people have a falling out like that. Yeah.
Especially in the public sphere, when, it's all laid out, on Twitter and stuff.
Yeah, I mean, it was only a month or so before the event, and it's pretty crappy to pull out at that time, especially over something so spurious. It was almost entirely a misunderstanding on Graham's part, but he seems unwilling to budge on that. And from where I'm standing, it's almost entirely to do with that Malcolm Bendall guy that Randall's friendly with and George is friendly with. The other stuff is like, in my opinion, it's an excuse to justify that.
Wow.
Yeah.
But, I mean, they've managed, at the 11th hour to get some new speakers, haven't they?
Yeah, so they've got Scott Walter and they've got Luke Cavans. Luke's a pretty cool guy. He's similar to me. He went to study archaeology after learning about Graham Hancock's theories and stuff.
Oh, wow. So was it Hancock that led you into archaeology?
Yeah. So in 2017, I saw the podcast with Randall and Graham on Joe Rogan.
Right.
And that inspired me to enroll in university and study archaeology and geoscience.
We told you to go to uni, Phil.
So this is something that was on my mind before we started recording today, was like perhaps, we've spoken to quite a lot of people around, this shift in ideas, I guess, around sort of like, what's considered the mainstream now, and new generations of archaeologists, geologists, or whatever you want to call yourself, that can change the narrative, perhaps, or put new theories forward that perhaps are currently unwilling to appear, I guess.
Yeah, there's definitely quite a lot of that happening. A lot of people who are going to university now are equipped with these new ideas. And coming into university, I was all in on Graham's theory of a lost civilization and a lost global civilization. And I think his core thesis is correct, that we're a species with amnesia. And obviously I'm very on board with the Younger Dryas Impact hypothesis, obviously. And that cataclysm would have had major consequences. But I don't know if I'm on board with everything that he says. I'm definitely not. He and I disagree on probably more than we agree on now.
Yes, I know what you're saying. You can accept some things and not others. Just because there were major cataclysms doesn't mean that we had, high technology 30,000 years ago or whatever.
Yeah, exactly.
But the possibility is there, but it's unproven.
Yeah. And particularly in South America, there's a lot of archaeological evidence that's not really talked about of potential human occupations up to 50,000 years ago. There's about half a dozen sites with pretty good dates of archaeological evidence that dates human occupation back to about 50,000 years ago.
Right.
And a recent study from last year, actually, they found a genetic Y chromosome bottleneck in South America, and they attributed that to the Younger Dryas Impact Event. So whatever civilization was there, they're not there anymore, and they disappeared around the onset of the Younger Dryas, which is really interesting.
Is this that thing where when it gets colder, there's more girls born than boys? Is that right?
So that's a different study.
Oh, right.
And that's one theory to explain the evidence that they're seeing in that study. So the temperature thing being related to the sex of the person being born, that doesn't really apply to humans. It interestingly, it does apply to reptiles like turtles. Temperatures determine sex in reptiles when they hatch, but not so much humans. So,
I mean, the interesting thing about what you mentioned about civilization possibly being found in South America 50,000 years ago, I mean, is the prevailing theory still that South American population was like 12,000 years ago, when the ice corridor was? So they came across from Siberia and then moved their way south.
So that was the theory for a long time. And so Monteverde in Chile, that really threw a spanner in the works there, because there's really well accepted dates there from 14,500 years ago or so. And obviously you wouldn't expect people to arrive in Chile before they were in North America. The ice-free corridor wasn't open at that time. So basically the ice-free corridor has been mostly abandoned, but in favor of a coastal migration. So they came along the coast either in boats or walking when the sea levels were low.
Do we know why they moved? Because in my experience, humans tend not to move unless they have to.
Well, there could be any reason for them moving. Obviously, there was something that made modern humans leave Africa about 120,000 years ago. They dispersed pretty rapidly throughout Asia, and they reached Australia by 65,000. So, I mean, there's plenty of reasons for people to move.
Yeah, I suppose.
I suppose the human spirit is really into exploration.
To boldly go where no man has gone before. It's part of it's the hero's journey.
Yeah.
It's the monomyth.
Yeah.
It's an archetype, isn't it? They were sharing our DNA.
Yeah.
And some scientists think that there's been interactions between populations back and forth. Like, people think of it as like a braided stream moving across the landscape, where some people think of it more like a series of pools that, like, the outer edges of the pools move back and forth. It's hard to explain, but basically different groups interact back and forth. There's cultural and technological and gene flow, actually, back and forth between cultures.
Yeah.
So the earliest lithic technology in the Americas is very similar to stuff they find in Japan. It's fluted technology. No, that's the Clovis. So it would be stemmed technology. So it's basically like if you picture an arrowhead with a stem on it, that's what they were, as opposed to the big spearheads of the Clovis people. They're very different technologies. And those have been dated to about 14,000 now in the northern North America. So
yeah, I'm keeping my eye on these LiDAR surveys that keep cropping stuff up in South America. They're interesting.
Yeah, I'll just stop this screen share.
Yeah. Yeah, they're using these drones with LiDAR and penetrating the...
We've got a mark within a mark.
Oh my gosh, sorry. Yeah, sorry, I'll do that. Yeah.
There we go.
Yeah, these they keep finding these like long roads connecting villages and towns together. Massive,
That's crazy, isn't it, those
massive
things?
civilizations that have just been eaten up. You know, the land's reclaimed it all.
Yeah.
There's just so much missing, and that's where Hancock is right. We are a species with amnesia. We only have half a story, if that.
Yeah.
Yeah.
It's generally Eurocentric,
Yeah.
you know, because of the nature of the way things have evolved and empire, and there's a million different reasons, and the age of exploration and whatnot. So, yeah, the more we can shed on this stuff, the better, I think.
Agree.
Yeah.
And one thing that Graham's definitely right on is that sea levels were 150 feet lower than they are today, and most of the archaeological evidence from that time is now underwater. So, and we're basically dealing with fragmentary evidence of settlements that were higher, like away from the coastline. That's basically all we have to go on from those times. So, yes, the archaeological paradigm is very incomplete in terms of knowing what people were up to back then.
Yeah, absolutely. Well said. Anything else you want to say about the Cosmic Summit before we wrap up? We've done over an hour already.
Wow, time flies.
Yeah. Other than buy some tickets, obviously. Links in the show notes.
Yeah, so there's still live in-person tickets available. I think they're 500 USD, which is out of a lot of people's range. But if you can catch the live stream for 49 USD, and I'm not sure if that's still going on, but buying a live stream ticket will get you access to a Discord channel where we can talk to people, the speakers at the summit, and talk to each other. And I think the plan is still to do exclusive interviews with people in the alt history space, and maybe even like have chats. So, for example, if you buy a live stream ticket and you go in the Discord, you might have the chance to talk with Randall even. So.
Cool.
Yeah.
Randall. Shame I'm not allowed a Discord anymore.
No.
I'll have to get a dummy email address and sign up for Discord again. Yeah. Well, Mark, this has been fantastic. We should let you go and go back to bed.
Oh, yeah.
Yeah.
Yes, it's just about to go 6 a.m. here. So
well, stay up.
Yeah.
Yeah, pretty much. Yeah.
Okay, we shall wrap up this part of the show.
Yeah.
Thanks again for joining us, Mark. Links are in the
Thanks
show
for having
notes.
me, guys.
No problem.
No problem. Good
Stay
talk.
on the line for us for 1 minute while we play ourselves out. And the rest of you in YouTube land who are watching live, we'll be back in 10-15 minutes for part 2. Do some news, okay?
Yeah.
Right, sayonara.
Late.
Bye.
See ya.